Alright, for those who are wanting to use a wideband on their old turbo Dodges, specifically I'm using a SMEC based one. If you want to run a wideband signal to the ECU and log the output so you can tune it properly, what you'll need is a custom chip. And now what I'm using is a Motes Ostrich 2.0, so I can live tune this, so that's what I'm using. But you can also just have a chip burned with the boost button, wideband to narrowband conversion turned on, and that you should be good to go. You'll also need a wideband controller. In my case, I am using an AM Yugo, I think is what they call these. And so these have a output on them that you can run into whatever source you want to log them with. So in this case, one of these wires, which I believe is the white one, we'll get to that in a moment, will be coming out and then being pinned into the ECU. And for the ECU, I'll put a pin out on the screen here, specifically for the SMEC, and that's what I'm using in this case. So here you'll see on the main connector here, on this specific wiring harness, it's supposedly pin 23, which is, you'll see these numbers up here. This is 41, 21, so we got 21, 22, and 23. So we'll just depin 23 by pulling out this red part and pulling out the pin. Alright, so once you have the actual brace taken out, so we're trying to disconnect pin 23, which is this one right here. So I should be able to just push this out, unless there's a lock in it, which, let me look down there. Looks like there might be. There we go, got the lock out, so now I should be able to pull on it, and this is a pretty tight harness. See if I can get this in there without cutting it. There we go. And there's the pin. So now what I do is make another one of these with the correct stuff on it. We're going to go from the wideband and pop that in there, and then we should have a narrowband signal going into the ECU itself. Alrighty, and here's it all wired in. So here I added a white wire going into the cab, which runs into underneath the dash where it's kind of spliced together. And then from there, it goes into the ECU, pinned into that pin, using these connectors. I'll put the part number up on the screen here, and where I got this from was from Jacob Kinet from Kinetic Creations. He makes wiring harnesses and other goodies for Neons and SRT4s and PT Cruisers and stuff. But because a lot of the stuff from this generation till PT Cruisers and SRTs are kind of the same, he actually sells us the pins for these, because I think that is the same pins they used up until like 1996. So normal like first gen Neons use this. So anyway, pack of this, they were about, I think, 50 cents a piece plus shipping, so reasonably priced, and I got extras just in case. So let's show it what it does. Okay, so we got it all pinned in, got the AFR gauge plugged in. So let's go ahead and get to the tuning part. Okay, so here we are in the tune. And the first thing we're going to do is we're going to set up, then cal configurations, then cal custom option config flags, and then we'll want to enable the wideband to narrowband conversion. So check that box. So by checking this box, you are now enabling underneath turbinator features under wideband to narrowband. This entire area will now be enabled. So now we have to go in here and adjust these three tables based on what sensor we're using. So the first table, which is narrowband offset value, I like to go ahead and set this to 0. So I'm just going to click somewhere around the middle here, and I think about the closest we're going to get is at 0.010. So call that good. And the point of this is to change the value of your narrowband, or what you want your narrowband to look like, because no matter what, your car in the end will still be running on a narrowband, but it will be using the wideband as the input through
conversions through here, and I'll explain that in a moment. Alright, so under wideband AFR to O2 transfer, so what this table does is converts your wideband signal, which comes from, or goes into here, whatever comes out of here goes into this table here and converts it. So just as for the clarity, I'll start on the third table actually. So go to AFR transfer function. Now, what you want to do is figure out how your AFR gauge is scaled. So I am using a 0 to 5 volt output on my AEM, and 0 volts on my AEM means 10 AFR, and 5 means 20. And you'll see based on this right here, you'll see here right here it says 0 volts, which is equal to 10 AFR. And you can also scale this for lambda if you want to, and I'll show you how to do it in a moment. And as you see here, as it goes through the voltage range from 0 to 5, it'll end up at basically 20. So we'll go back to the tune, and the first thing we're going to do is down on the bottom, because we're only working from 0 to 5, so here's 0 to 5 for the volts, we're scaling that, that's correct. Now, because my gauge only reads 10 for the minimum, I'm going to set that to 10, and I'm going to put the max to 20. Alright, and now on the output ratio up here, we'll see 0 volts is output to 13, and that needs to be 10. So because we scaled this from minimum of 10, 10 is actually down here in this very bottom corner. So the coordinates of 0 and 0, so we're going to change the Y value over here to 0. So now it's down the bottom left corner, and you see it's 10 here. Now, because this is using hexadecimal, 255 is the max range here, so we're going to change this to 255 also, so it goes in the very top right corner. So that's 5 volts. So now the scale is from 10 AFR to 20 AFR, or 0 volts to 5 volts. So now that we got that set, we go into the second table here, and this is where we convert this into a narrowband signal. So what's happening here is once you enable this feature, the routine that checks how much, or the O2 sensor, now checks these outputs first. So what's happening is it takes the 0 to 5 volt, converts it into the AFR signal. So we'll say if we're getting right about right here, 2.5 volts, you'll see on the y-axis that is 15 AFR. So whatever voltage the computer sees, it'll move it along these two axes here, and it'll give an output of your actual AFR. It'll take that number, feed it into this wideband AFR to O2 transfer, and what this is doing is you'll see these numbers right here, 14, 15, 19, and 4. Those are your actual AFR. So whatever number comes in here, it'll plot it on this route here. So if it's plotted on this plateau right here, this is, let's see, this would be rich, and then if we plot it on this plateau right here, this is somewhere in stoic, and if it plots it over here, it is lean. So what we're going to do is scale this as well. So down here, see for our air-fuel ratio, it says minimum of 4. Well, since my gauge only reads 10 to 20, I'm going to change my minimum to 10. I'm going to change my max to 20. Alright, now that kind of messes up the scaling here. This stoic point, now it thinks stoic is 16.7. So we need to move this over to the left, so I just selected it, and I'm going to use the left arrow key, and I'm going to watch up here on this input ratio. I want to get to about 14.6 if I can, so that's slightly rich. So 14.6, I'm going to call that good. And then we'll go to this other one here, and we'll move that to about 14.8. So about, right there. We'll call that good. And if you look online to see how an O2 sensor reads, like an actual narrowband, you'll see it pretty much, it looks exactly like this. It goes, oh, over here you're rich, you're stoic, and you're lean. That's all it knows. So it just sits there and bounces back and forth, trying to stay on this up and down point right here. Alright, so this looks all good. So that's all scaled correctly. And like I said, this narrowband transfer, so once it gets out of this spot, this is what's actually sent to the computer. This is where you'll see this voltage output right here, where 0.9, 0.9, 0.9, whatever, right? So this is what's actually feeding into the computer here and determining what the computer should be running on. And so you'll see down here it says 0.0 and 0.09 and 0.9 and 0.8. So basically it's bouncing between rich, lean, rich, lean, rich, lean real quick. And if for some reason, and I'm not really sure why you'd want to do that, if you want to change this voltage that's coming out, like these ones right here, you can use this offset value to mess with it. But ideally you shouldn't have to do that. But now that this is all set and scaled, we'll go ahead and flash. It's reading right down here. Flash it. Alright, cool. So now from here, we're going to do the most important part, which I think is the biggest feature of doing this, is now we're going to set up MPScan to actually read this AFR ratio so you can actually tell and log what's going on, what the car actually sees. So I'm going to pull up MPScan real quick and I'll show you how to do that. Okay, so here I have MPScan open and I just have some blank templates right now. I don't have any gauges set up. If you already have gauges set up, you're going to want to delete your AFR ones because they're not going to be scaled correctly. So first thing we're going to do is go into the template. So we're going to go to display layout, and I'm just going to pull up one I made for this video. So I'm going to do video layout. Okay, so here's my gauge. So now that we have AFR defined in the tune, now we need to define it and scale it the same way in MPScan. So we're going to go to settings, layout files, then gauge settings. Okay, and right here we have AFR O2 value, which is AFR command. And we'll go over here to the left and say display minimum 10, display max 18, which is probably fine because if you're reading over 18, you shouldn't be driving your car anyway. And then we'll see ECU minimum 10, so that's correct. So yours might say 4 or 5 or something like that, but basically on the ECU minimum and maximum, you want to put it to what your gauge is. My AM is 10 to 20, so this is 10 to 20. And then we'll go down and check the other O2 values. I believe there's one that's O2 somewhere at the bottom here. Okay, so here it is. We got O2 sensor value and O2 sensor volts. So the O2 sensor volts is the actual voltage coming from your gauge going into the computer. So mine is 0 to 5. So if yours is different, change it to your correct value here, but here's 0 as my minimum, 5 as my maximum. And I've also scaled the O2 sensor value to the same thing, which I don't think it really matters as much because that's technically a 0 to 1 volt value. That's what the actual computer sees. So that one doesn't matter as much. So now that we got those scaled, we can go ahead and close out these settings here, or hit save, my bad. Saved it. Okay, close this. And now we're going to want to make our new gauge. So first we're going to go to AFR command. This will be the gauge to see what the computer's wanting at the moment. So we'll set that off to the side. Make another gauge. And we're going to do AFR wideband. So this will be the input, or what your actual wideband should be seeing. And if this is scaled correctly, it should read from your 10 to 20. So my gauge, I have the minimum set to 8 and the maximum of 18 because if it's down to 10, it should be popped right around the side here. And then we'll add another gauge. and we'll go to O2 voltage. Okay, then we'll add one more gauge. This one will be O2 value. And again, to explain what these all are, AFR command is what the computer is commanding at the moment. AFR wideband is what the car is currently reading. Ideally, these should be the same, if your tune is correct. The O2 voltage is the direct raw input from your gauge into your computer. Now, using this scale, you should be able to double check to make sure that your AFR is matching your O2 voltage. So if that gauge says 1.4 volts, you should be about 12.8 AFR, and ideally you should be on this gauge right here getting 12.8 AFR. So this is I just use this to double check. And the O2 value is what, through all those maths and tables, what is feeding into the fueling table. So this O2 value should be pretty similar. You'll probably see it bounce between lean and rich back and forth, but that's just to see if it's scaled correctly. If you mess with that O2 offset, you'll see this kind of look a little weird. All right. So now that we've got those all set, go ahead and save our layout here. I'm going to close that. I'm going to close my profile, reload my profile. There's my gauges. All right. And now it's time to see if it all works. So I'm going to hit here, key on, hit record. All right, so there's the values here. And I'm looking at my wideband. That's pretty close to it, slightly off, but you can sit there and kind of readjust everything. So I'm going to turn the car on now. Okay, looking at the gauge there, the AFR wideband is pretty correct. And the AFR command, let's see why it's having a problem. Alrighty, so I got it working now. So what I had to do was delete the gauge, go back into the tune, double check that, make sure that everything I set was there. And when I saved it, I guess I didn't save one of the tables, so I resaved it, reflashed it. Now we're good to go. So I'm going to put the key in the on position. I'm going to hit record. And as you should see, when I turn the car on, the AFR command, AFR wideband should be almost identical. The O2 value and O2 voltage should be about the same. So I'm going to go ahead and turn it on. Well, there you go. Now that they're reading the same. So now you should be able to log all this. So if I hit stop here, there we go. So using this, you should be able to now log and be able to use a correction factor. You can actually use this AFR wideband to now feed back into the computer using one of the tools built into MPTune to actually correct the actual AFR versus requested, so you can get them closer together. But I think we're all set here. So if you guys have any questions, let me know. I'm learning as I go as well. So if there's any mistakes in this video, please let me know in the comments. I'm always up for learning and fixing anything I can. So, all right. See you guys later. Have a good one.